So good morning, good afternoon, everyone, and welcome to our webinar. My name is Vaiani. I'm the Secretary General of the World Energy Council France, the French member committee of the World Energy Council, and also have the honor of chairing the Energy Committee of the WFEO, the World Federation of Engineering Organization. For those who are not familiar with WFEO, the World Federation of Engineering Organization is a global non-governmental organization that represents the engineering profession worldwide. It has been established under the auspices of UNESCO, and it brings together a network of 30 million of engineers across more than 100 countries, and with them a large and valuable pool of expertise. WFEO operates through 13 specialist committees, one of which is the Committee on Energy. And what are we doing to advance the SDG 7 through engineering? As engineer, energy engineer, and scientists, we all share a responsibility for identifying and implementing the most effective technology for sustainable development. As chair of the Energy Committee, I strongly believe that international cooperation and sharing of knowledge, including best practices, efficient energy policies, and technological innovation are key to achieve SDG 7, affordable and clean energy for all. And this is the guiding principle of our work within the Energy Committee. Among our initiatives, we have launched our 2025 webinar series with a presentation in January by one of our task groups, focusing on electrification access gap and policy recommendations to address it. Today, we shift our focus to another dimension of the energy transition, the role of nuclear energy. And it is therefore our pleasure to welcome Dr. Henri Paillere, who is head of the Planning and Economic Studies section at the International Atomic Energy Agency today, and also, like myself, a proud member of the UN Council of Engineers for the Energy Transition. And Dr. Paillere will explain to us today why nuclear power is making a comeback. After that, you may ask your question in the chat, and Dr. Paillere will answer it at the end of its keynote. So please, Henri, I give you the floor. It's great to listen to you today.
Thank you, Marilyn, and thank you for the opportunity to speak in your webinar series. Let me try to share my screen and my presentation. Okay, I hope you can see it now. So the title is maybe a little provocative. Why is nuclear power making a comeback? Actually, these words are not from me. They're from the executive director of the International Energy Agency, Dr. Fatih Birol, who said a few months ago when the IAEA was launching a report on nuclear power that indeed this technology is making a comeback. So I will try to explain why, what are the reasons why we are talking about nuclear power again now, and what are the drivers and the challenges facing this technology. So the outline of my talk is just to give a few numbers for those that don't have a clear understanding of what nuclear power represents today and what it could represent tomorrow. And then I will go through some of the, I would say, the rationale for supporting a comeback of nuclear power. Maybe before I start also, just a few words on the International Atomic Energy Agency. It is within the UN system. It is a specialized agency looking at nuclear power, but not just nuclear power, but also nuclear technology for health applications or agriculture or many other applications. And we have about 190 member states. So almost all the member states of the UN are also member states of the International Atomic Energy Agency. So let me start. A few numbers concerning nuclear power. So today there are 31 countries that have a nuclear power program generating electricity, and these nuclear power plants in 31 countries represent about 9.2% of the share of the global electricity production. This share of 9.2 has been going down, I would say, the last 2 decades. In the mid-1990s, there was almost 18% share of nuclear electricity worldwide, but with low levels of investments and also deployment of other technologies, including fossil fuels, but also renewables in the last 15 years, I would say, this share of nuclear electricity has gone down. But still, nuclear power represents almost a quarter of the world's low-carbon electricity, and this plays an important role in terms of climate change mitigation. I mentioned 31 countries operating nuclear power today, but we have about 30 additional countries that are looking at nuclear power and planning to embark on a nuclear program at some point. The IAEA provides assistance to these member states to help them build the necessary infrastructure to be able, if they make the decision to build, to operate nuclear power plants in a safe way. Among those 32 additional countries, there are 3 that are building a nuclear power plant: Turkey, Bangladesh, and Egypt. And they will soon join the 31 countries operating nuclear power. So why are we saying that nuclear power is making a comeback, and what are the drivers for this, I would say, revival of nuclear power? Well, first of all, the low carbon characteristics of nuclear power. I think there are always some debates about how low carbon, what is the carbon intensity of nuclear power over the full life cycle of the technology. But I'd like to refer to a recent report from the United Nations Economic Commission for Europe. They produced a report in 2022 looking at an integrated life cycle assessment of all electricity generating technologies. And they found that actually nuclear power has the smallest carbon footprint among low carbon technologies. We have estimated that over the last 5 decades, nuclear power has avoided about 70 gigatons of CO2 globally. So that's on the low carbon side. The sustainability is a little more challenging, and there were a number of discussions, especially in Europe, regarding the inclusion of nuclear power in the taxonomy of sustainable activities. And one of the points that was raising a question was the way the industry was managing the waste from the operation of nuclear power plants. The Joint Research Center of the European Commission produced a very thorough report that concluded that actually nuclear power is no more dangerous than any other technologies that had already been included in the taxonomy, and showed how the industry knew how to manage its waste. And I've added a little picture because ultimately at some point the radioactive waste will be disposed of in deep geological repositories. This is the solution that all countries and scientists and regulators have agreed is the solution. So these deep geological repositories is the solution, and Finland is leading the world in terms of implementing a first deep geological repository. So that's on sustainability. Safety is also a matter that raises a lot of concern, but we'd like to look at the numbers. And here on this chart, I've looked at data from Our World in Data, where they look at the number of fatalities per technology per kilowatt of electricity produced. And you see that nuclear energy is actually one of the safest technology around. Yes, there have been some accidents, but they haven't created so many fatalities. There have been radioactive contamination of soils, as we know in Japan. It has a cost, but in terms of fatalities, overall, the data shows that nuclear is actually safer than wind or hydropower, and much safer than coal or other fossil fuels. One of the reasons why we're looking at nuclear again today is the way our energy systems and our electricity systems are evolving. We know that there is a strong build out of variable renewables, and this poses a challenge for the electricity systems. And nuclear power has a number of attributes that are helping to integrate large shares of renewables. First of all, it is a dispatchable technology, meaning you can generate whenever you need it. It is flexible, even though there are some people that say that nuclear is not flexible, but there's experience, especially in France, which had from the start the plan to build a very large fleet of nuclear power plants and to adapt to the demand changes. For example, at night, the reactors were designed to ramp down at night so as to reduce production. Now we're integrating technologies that have variable production, so you also need to adapt to variable production across the day. What is important is that you need this kind of dispatchable technology and a low carbon one. So for countries that have a lot of hydro, maybe they don't need nuclear, but for those countries that have limited hydro resources, nuclear could be an important option. A very important important aspect also of the transition is the overall cost of the system transition. And what we have found, what a number of institutes have found, is that if you have nuclear in your system, you don't need to overbuild your renewable capacity, you don't need to oversize your storage, and so the cost of flexibility is less, and it translates into a lower overall cost for the system when you have a nuclear as part of the mix. Security of energy supply has been an important driver in the last couple of years, and nuclear helps to contribute to the security of energy supply. And in a way, it's a little similar to how the nuclear fleet expanded in the 1970s following the different oil shocks. And what countries have rediscovered is that having nuclear in their mix helps to secure energy supply. The cost of the nuclear generation is not so sensitive to the cost of uranium. Uranium resources are widely available, though there are some geopolitical constraints. Nuclear fuel can be stored on site very easily. And in the long term, thinking of limited resources of uranium, you have technologies that recycle the spent fuel in multiple way, so-called fast reactors with closed fuel cycles, and they would have the advantage of being able to produce for the same quantity of uranium about 60 times more than the current technology, 60 times more energy. An important aspect also of nuclear power is that in terms of dependence on critical minerals, it is, according to the International Energy Agency, one of the low carbon technologies that is the least dependent on critical minerals. Climate resilience is an issue that faces all the countries undergoing their transition. We know that climate change and extreme weather events will impact all technologies, including nuclear power, and can affect the resilience of our future energy systems, our current and our future energy systems. Diversification of the mix helps to address the resilience of the overall system. But from an individual point of view, we have looked at a lot of data. We at the IAEA we have a database that contains all the operational data of all the reactors for the last 3 decades or more, and we've analyzed all the weather-related production losses affecting nuclear generation. For example, in summer, when you have heat waves or droughts, and some nuclear power plants have to reduce their production, that translates into a production loss. So overall, in 2022, about 0.35% of the global nuclear generation was lost due to weather-related events. So it is there, but it is maybe more limited than people might think. And I'd like to show the picture on the right, the photo. This is the Paillere generating station. It's one of the largest nuclear power plants in the US, and it's in Arizona. That doesn't have a lot of water for cooling, but it has an original source of cooling water. This water comes from treated wastewater from the city of Phoenix, a few kilometers away from this power plant. So just to show that there are technical solutions as well to issues such as cooling for nuclear power plants. An important aspect also that maybe has not received enough attention, not just for nuclear, but for the whole energy sector, is the need to decarbonize beyond electricity. We talk about electrification, and if we have a source of low carbon electricity, then electrifying transport or other applications with low carbon electricity is a way to decarbonize. But there are some sectors that will not be that we will not be able to electrify, and for those sectors we need sources of low carbon heat or low carbon fuels such as hydrogen. And nuclear has a huge advantage, I would say, over all other technologies, is that it's a source of low carbon heat. Actually, before it generates electricity, a nuclear power plant is a source of heat, a boiler that provides low carbon heat. So there is experience, actually more than 3 decades of experience of using heat from reactors for heating applications, in particular district heating. There are countries like Switzerland that have been using nuclear district heating for more than 30 years. This was also used in former Soviet Union countries. China has been developing nuclear district heating more recently to address on one hand, greenhouse gas emissions, but also, and perhaps more importantly in this case, the reduction of air pollution, the smog that you have when you have coal-fired district heating. That's for, I would say, low temperature heat, but there's also the need to provide process steam heat for industry at much higher temperatures. And their advanced reactors, such as high temperature reactors, can produce such heat. And there's a project in the US, for example, between Dow and X Energy, which is a designer of a small high temperature reactor, to deploy nuclear reactors to provide heat to these chemical plants. Hydrogen as well at some point will also play an important role. There are different ways of producing hydrogen. What we like to say is that it is the carbon content of hydrogen that's the most important, not the color coding of hydrogen. And there are a number of projects that are assessing the production of low carbon hydrogen. I would say cost is currently an issue, and producing hydrogen from nuclear, which is an expensive source of electricity, is challenging in current circumstances. So a few words now about nuclear power and its contribution to climate change mitigation. we'd like to refer to the sixth assessment report of the IPCC, and in particular the work of the Working Group 3 on the mitigation of climate change. We've looked at all the scenarios that are in the sixth assessment report. There are over 1,800 scenarios. About half of them are scenarios that are compatible with the goals of the Paris Agreement, which is global warming under 2 degrees by the end of the century. We went a little deeper into the scenarios to see, well, how much nuclear is there, and what we found on this chart, you see all the scenarios that are in blue or green are those consistent with a 1.5 or 2 degree global warming. You see two things. First of all, increase in final electricity consumption. So this is in line with the understanding that we will need to electrify our economies greatly. There's also a reduction in final energy consumption. That's also a very important factor. Now, in terms of this electricity, this low carbon electricity in those scenarios, well, not surprisingly, there's a lot of renewables, but we see a lot of nuclear as well. Actually, most of the scenarios in the IPCC sixth assessment report see an increase in nuclear capacity, sometimes a substantial increase in nuclear capacity compared to today. This is I would say, in the core of the report. Unfortunately, the summary for policymakers goes through a process of filtering, and it doesn't mention nuclear, even though when you look at the actual data of the scenarios, there is quite a lot of nuclear in these 2 degree or 1.5 degree scenarios. One of the major outcomes of a recent COP, COP28, which was held in Dubai in 2023, was the mentioning of nuclear in a consensus document. The consensus document was the first global stocktake. So this was the first time since the Paris Agreement in 2015 that the parties came together to assess the progress in terms of meeting the decarbonization goals. And this COP, the 28th COP, is the first time in 28 COPs that nuclear was explicitly mentioned. I mean, this is I would say, a sign also that nuclear is perhaps on its technical merit would have been recognized earlier on, but as a technology that helps to decarbonize. But there's some political pushback by some countries. But anyway, at this COP, it was recognized at last. And also, I would like to mention, on the margins of COP28, there was a pledge by 22 countries to triple nuclear energy by 2050. At the last COP in Baku in Azerbaijan last year, this number was increased to 31 countries. So 31 countries also calling for a tripling of nuclear capacity by 2050. I mentioned it just at the beginning, Dr. Fatih Birol, but I really would like to pay tribute to his vision and to the work of the International Energy Agency with respect to nuclear power. They have done their own scenario analysis, and they have concluded that it is impossible to reach net zero globally without nuclear. There's one report that addresses the pledges of COP28, from taking stock to taking action. I really recommend our listeners today, our viewers, participants, to look at this report. It shows how it shows how to meet the tripling of renewables by 2030, the doubling of energy efficiency, but it also highlights how nuclear can help support achieving those goals. And the IAEA recently launched a report, The Path to a New Era for Nuclear Energy, that came out in in February 2025, and that's when the IAEA said that nuclear power was making a comeback. So that was for the International Energy Agency. Let me share with you some of the our own projections at the International Atomic Energy Agency. Every year we publish projections in terms of nuclear capacity up to 2050. This is an annual exercise. We have a group of international experts. We go country by country using a bottom-up approach, looking at existing nuclear plans to extend the lifetime of the existing fleet, or plans to build new reactors, or plans in newcomer countries to embark on a nuclear program. And we consolidate all the data into regional projections and global projections. We have two cases, a high case, which is the most optimistic one, and a low case. And on this chart, what you see is how the high case and the low case have evolved since 2010. So 2010, it was, I would say, the end of what we call the renaissance of nuclear power in between 2004 and 2010. And in the high case, we were projecting up to 1,400 gigawatts of nuclear by 2050. 2011, the Fukushima accident in Japan, and I would say for the next 10 years, a growing pessimism that nuclear would play a role. But around 2020, we saw this turnaround. This turnaround was, we think, came from the realization that countries were not on track to meet the goals of the Paris Agreement. There was an energy security, energy crisis due to the war in Ukraine. And in the last 4 years, year after year, we've seen a growth in optimism that nuclear would play an important role in the future. And last year, our high case projection showed not a tripling of nuclear power, but a scaling of 2.5 up from about 372 gigawatts to 950 gigawatts of nuclear. What's interesting is looking at all the additional capacity that would need to be brought in, besides extending the lifetime of the existing fleet. And what we saw was that to get to 950 gigawatts, we need to build about 640 gigawatts of new nuclear capacity. Most of it is made up of large reactors, so basically the technology that we have today. But we saw about 24% of this new build was made up of this new type of technology called small modular reactors. I'll get to small modular reactors in a minute, but I wanted here to show you this chart where we have our IAEA high case and low case projections. We see also the IAEA net zero scenario, the 2023. There's an update that I should put on this chart, and also where the tripling pledge would see the world going in terms of nuclear capacity. There's also a recent net zero scenario from Bloomberg New Energy Finance. So the question is this a second renaissance of nuclear power? Well, to make it happen, there are a number of challenges that need to be addressed, from developing a robust supply chain, having the human workforce, the resources, but also financing. And I just wanted to have a quick word on financing. We've estimated that to get to our high case scenario, we would need to have global investments in nuclear power, which over the last 4 or 5 years have been around $50 billion a year. would need to increase to 125 or 150 billion a year for the tripling case. There is a need to mobilize investments for that. Just as an order of magnitude, as some of you know, at COP28, there was this pledge to triple renewables by 2030. IRENA, the International Renewable Agency, has estimated that to get to this tripling of renewables by 2030, the yearly investments for renewables is $1.5 trillion. So just to say that the investments for nuclear, the yearly investments for nuclear are about a tenth of what is needed to build the renewable capacity. There's also all the investments that need to be made into the grid infrastructure and so on. But just to point out that we hear sometimes the argument that investing in nuclear would take money away from investments in renewables, but really the scale of the investments that are needed are quite different. I mentioned the challenge of mobilizing finance, and one major concern for financial institutions and banks is the risks linked to the construction. This is the risky part of a nuclear project, and so there are a number of I would say best practices that we have observed to ensure that the industry is able to build on time and on budget. And some of the I would say key factors are on this slide: having a standardized technology, having a commitment to volume and construction by series within a country or within a region. Just building one reactor and nothing after within the next 10 years, this is not how the costs are going to go down. Having an effective interaction with the nuclear regulators, having a strong, robust supply chain workforce, and also the ability to take on learning costs, especially for first-of-a-kind projects, in particular small modular reactors, which are still, I would say, for most of them, at the stage of a paper design. There are different ways of mobilizing these investments. The role of governments remains very important in terms of de-risking investments, but what we're seeing increasingly is the interest of the private sector in providing support to nuclear power projects, and this is an ongoing, I would say, action from multilateral development banks, which up to now have been excluding investments in nuclear power, but quite recently the president of the World Bank has made a statement that he was going to ask the board of the World Bank to end the moratorium on financing nuclear. So that would be a strong signal for other multilateral development banks, but also a hope for countries, especially emerging market and developing economies, that they would be able to have access to finance from multilateral development banks. I mentioned quickly small modular reactors. I think this is one of the reasons also why we're talking a lot about nuclear today. So what are small modular reactors? So at the IAEA, we have a catalog or a survey of all the designs that are going. We have more than 80 designs today, and these designs are categorized in different types of technologies. Actually, SMR is not just one technology. There are different types of technologies, but they all have individual merits. So why are we talking about small modular reactors? Because in the last 60 years, actually, the trend has been to build bigger and bigger and bigger. The large reactors that we have today rely on what we call economies of scale. When you look at the first pressurized water reactor, shipping port PWR in 1958 in the US. Its size was 60 megawatts. You look at the largest pressurized water reactor today, the EPR reactor here, the one in China, Taishan 1. There's a scale of 30 in 60 years. So SMRs would be something like, is it back to the future? And why? And we think that basically the energy markets and the electricity markets of tomorrow will be quite different from the ones we've had over the last, I would say, 3-4 decades. We will have systems with higher shares of variable generation from wind, from solar. We will need more flexible, dispatchable power. We need technologies that are able to maintain grid stability and also to provide heat or hydrogen for non-electric applications and decarbonization. So this could be a role for SMRs. Some of the characteristics of SMRs, better affordability, shorter construction time, site flexibility, and integration with renewables. But this is quite theoretical because there are very few SMRs in operation today. Actually, we identified 2 at the IAEA. One is a floating nuclear power plant off the coast of Siberia that's providing electricity and heat. And another one is a high temperature reactor in China. There are 3 under constructions, one in China, one in Russia, one in Argentina, but a lot of other designs at different stages of regulatory approval. Actually, quite recently in Canada, the regulator gave the construction license for the first construction of a SMR, a BWR, from GE Hitachi, to be operated by Ontario Power Generation. I'll skip that because I've already mentioned it. I just want to say some new applications of nuclear power that we're talking about today that weren't in the conversation, let's say, even 5 years ago. One is related to the problem of coal. We know that burning of coal is one of the main sources of greenhouse gas emissions. And there are a number of countries that are looking at replacing coal-fired power plants, especially those that are towards their end of life, by nuclear power plants, in particular small modular reactors, because they are quite similar in size. And both a small modular reactor and a coal-fired power plants, basically they're thermal power plants. So they have similar type of infrastructure in terms of a turbine hall or cooling needs and so on. So there are different options to switch from a coal to a nuclear power plant, depending on how much of the existing infrastructure can be used. And the more infrastructure you can use or reuse, well, the more savings you can make for the whole projects. There is one project in the US, the Natrium project in Wyoming, which is underway. They started the construction site, and not yet the construction of the reactor, but the discussions are ongoing with the regulator. So coal to nuclear is something that we're talking about. And this year, the IAEA is working with South Africa within the G20 Energy Transition Working Group. South Africa has expressed a lot of interest in the coal to nuclear option. So we're developing a report for South Africa in that context. The other application that we talk a lot is artificial intelligence, data centers, and the demand for electricity and clean electricity that these big tech companies represent. And quite recently, on the margins of CERAWeek, which is a big energy conference in the US, big tech companies and other large energy users signed up a pledge to support the tripling of nuclear capacity by 2050. And the other topic that is starting to be discussed is nuclear propulsion for maritime transport. So this is not new. There have been cargo ships in the past. There are some Russian icebreakers today that operate with nuclear propulsion. There are military ships like aircraft carriers or submarines, but it didn't really, the technology wasn't adopted by the maritime organization. But this is really a hard to abate sector. Different options are being investigated, and the IMO, the International Maritime Organization, said they would start looking at the nuclear option to assess its viability. So this is an important development that we see could help reduce a lot emissions from the maritime sector. So just to conclude, so that we have a little bit of time for questions. Well, I hope I walked you through a presentation to show you how nuclear is making a comeback. We think that the circumstances are quite different from what we called the nuclear renaissance from 2000 to 2010. There is this climate urgency. There is increased need for clean electricity. Just a few years ago, the projections of electricity demand in OECD countries was quite flat, but in recent years, with the need to electrify the economy, the data centers, AI, countries are realizing that they will need a lot more electricity, and nuclear is becoming an option again. Maybe the realization that if you rely just on renewables and storage, you will not realize your transition. We think all low carbon solutions are needed, and for those countries that want to look at nuclear, they should be able to consider that technology. We will need decarbonized heat for industry, for maritime transport. Quite importantly, there are quite a few technologies on the horizon now: small modular reactors, advanced reactors, Gen 4 reactors that are also representing or raising a lot of interest from different parts of the industry and governments. Interest from the private sector, including financial communities to support. Interest from multilateral development banks. We will see whether this happens and whether nuclear will be back. I would say within the scope of what multilateral development banks can finance. But just to also say that the role of governments will stay very important for the development of nuclear power. So I think I have finished here, and Marilyn, I'm handing the floor back to you.
Yeah, thank you very much, Henri, for this very accurate and large presentation. We have a lot of questions, so I will start to consider some of them. First one is about SMR. Do you believe that the SMR could become the mainstream of nuclear energy in the 3 or 4 decades?
So I sort of answered that in my presentation, because I said in our projections to 2050, we still see large reactors being representing the bulk of the new capacity. But SMRs, they were not in the picture just a few years ago, and now they could represent something like 10-20% of capacity by 2050. So I don't think SMRs will become the main technology, but they're certainly part of the picture, and they can address some specific needs which large reactors cannot address. And
there are also questions about cost and flexibility, and I think maybe you need to come back to your presentation to explain the costs and probably the system costs. And the other question was about flexibility and how it is possible to use nuclear to better integrate renewable variables.
Okay. So yeah, I mentioned that nuclear power plants can be flexible, and we had the example of France, also Germany. They actually, in France, the reactors were designed to be flexible from the start. In Germany, there was some retrofitting to make them flexible. What we know is that having large shares of wind and solar will require a lot of flexibility. Now, I don't want to say that nuclear is the best option to provide that flexibility, because maybe there are other technologies that can provide flexibility at a lower cost than nuclear power. But the demand for flexibility will decrease if you have nuclear in your energy mix. So a system with no nuclear will have the need to provide a lot of flexibility to stabilize the system and ensure the supply, that supply meets the demand. But if you have nuclear power in your mix, then because you have a technology that's dispatchable, that's also provides base load for a lot of its operation, then the need for flexibility is less. This was clearly seen in the study by the French grid operator RTE, where they showed that their scenario without nuclear had a very large cost, I would say, related to the flexibility need, and that flexibility need was much reduced when they considered scenarios with nuclear. In terms of cost, so very often we hear nuclear is too expensive, and there's a reference to an important metric, which is the levelized cost of electricity. And on the levelized cost of electricity, I want to say two things. First of all, for the existing reactors, and especially for the lifetime extension of existing reactors, this is I would say, the technical option that leads to the least cost option for producing low carbon electricity. For new nuclear, the situation is a little different. The LCOE of new nuclear will be more expensive, is more expensive than the LCOE of wind and solar. But the LCOE is just one metric. When governments are looking at all the technologies and the investments needed to implement their energy transition, they need to look at the cost of the technologies, but they also need to look at the grid infrastructures, the cost of energy storage, the cost of flexibility, dispatchable backup power, and so on. And so this is where we start talking about the system costs. It's not just the cost of generation, it's the cost of integrating technologies within the system. And having nuclear in the mix reduces the need to overbuild storage, to overbuild or oversize flexibility sources, and this leads to a lower overall cost. Even if on an LCOE basis, nuclear is more expensive than wind or solar. But this is something that I think governments and policymakers don't necessarily understand. I think this is an area where we need to communicate better. And I know that this year there are a number of institutions that are going to publish reports about system costs, because in the end, this is what the consumers will see. It's the cost to the overall system, because the cost to the overall system will translate into the cost of the electricity for households, for industry, and so on.
Thank you, Henri. And for those who read French, we have published an article on system cost and the different scenarios. So I really encourage you to read it if you are interested in that topic. Another question about financing. What are the overall financing prospects for nuclear technologies, including small and micro nuclear reactors, in light of the World Bank recent openness to supporting nuclear sector?
Okay, so we looked at how much the World Bank has financed clean energy in the last couple of decades. Actually, the World Bank is not the main multilateral development banks in terms of financing clean technologies. The European Investment Bank provides more financing. But just to stay with the World Bank, it was around $5 billion a year. $5 billion a year for renewables, for grids, and so on. That's just a little drop in the overall need for financing. I mentioned figures such as $125 billion a year to finance the nuclear capacity expansion to get to a scaling of 2.5 by 2050. So we see that what role we see for multilateral development banks is to bring in to be able to do the due diligence of projects, to bring in other investors, commercial banks as well, adding credibility to projects. We really see that to meet the expansion of nuclear that we see in our high case projection, but I think it's the same for other technologies. There's a limit to how much governments can put in terms of money, whether it's developed countries or developing countries. The bulk of the investment has to come from the private sector. So what we see very encouraging for the nuclear sector is this appetite for the clean electricity that nuclear power plants can produce, including small modular reactors from big tech companies. So this in the US, and over the last 2 years, we've seen announcements by Amazon, by Google, by Microsoft, looking at really different types of investments. There are some investments to restart large nuclear power plants that were shut down for economic reasons, like 3 Mile Island Unit 1 was shut down in 2019. There are investments ongoing to restart this nuclear power plant to produce the electricity that the big tech company is looking at. There are investments to secure through power purchase agreements offtake from existing and operating nuclear power plants. And there are investments in small modular reactors. But we know that these investments, small modular reactors, will not be on the market, I would say, at a commercial level before 2030. And there's a need to have electricity now. So there will be investments in wind and solar that maybe have shorter construction time. But in the end, there's such a need for clean electricity that the nuclear will come into the picture, and we will see those companies investing in nuclear.
There is a question about heat, and coming back to his 34th slide about industrial heat and SMR. What do you think can be the most suitable industries for SMR heat?
So we see a number of countries looking at small modular reactors for district heating, like in Finland. But this is low temperature heat. And I would say the current technology of light water reactors, pressurized water reactors, whether it's large scale or small scale as in an SMR, can provide that district heat. For high temperature heat, process steam for industry, I think here we need to look at another technology among the SMR technologies, and I mentioned the high temperature reactors. They are able to produce steam at temperatures of typically 850 degrees Celsius or higher. So this is becoming really interesting for petrochemical companies, maybe steel, cement, and so on. So I mentioned the project in the US with Dow Chemical investing together with X Energy, but there are projects also in China with petrochemical industries. We've had discussions with the oil and gas companies. Also, they're looking at SMRs to decarbonize their operations.
There are questions about skills. Do you think we have the skills to develop the project we ambition to develop at the world level?
I think this is a major challenge. I think we need the industry needs to grow. We'll need skills. So we need young people to go to universities and engineering schools and go through an education, a nuclear education. But yeah, this is a real issue. It's a real issue for I would say the Western world, Europe, the US, where basically there's the workforce has aged and hasn't been replaced. But it's a different situation when you go to China, when you go to even Korea, where there's been I would say a constant flow of growth of the workforce. You look at Chinese universities and the number of engineers they create. It's impressive, and this is really a crucial point for the nuclear industry. Is having that workforce. So that's a challenge.
Maybe WFEO can help.
I hope. Yes, I'm sure. We rely on you.
There's a question about nuclear fusion, because we see a lot of startups working on developing fusion technology, and this may be quite surprising for some of us.
Yes, so at the IAEA we started looking seriously at fusion, no more as a kind of from the point of view of physics and science and so on, but looking at it as a technology to produce power. And indeed, we've seen all these startups that have been created, and some of them have been really successful at mobilizing investments from venture capital, from investment. We've seen some agreements that I find a little challenging. I think there's in the US, Microsoft and a small fusion company called Helion signed an MOU or some agreements that Helion would generate electricity for Microsoft by 2028. This seems very, very challenging, but at the same time, there's been a lot of progress in fusion technology. I think big questions about the costs, but I think when I said we need all low carbon technologies, that means wind and solar and maybe fossil with CCS and nuclear fission and also fusion. Yes.
There's a more sensitive question about the risk of developing civil nuclear and increasing the risk of non-controlled military nuclear weapons in the future. This is clearly a topic for your agency.
Yes, it is one major, I would say, responsibility of the IAEA to ensure that the development of a civilian nuclear program is done in a safe, non-proliferating way. We have, I would say, the bulk of the work of the agency or the regards the work of safeguards. We have inspectors going to all the nuclear facilities in the world, checking that the materials are not diverted and that civil nuclear programs can be developed. So I would say this is part of the package of nuclear power. We need strong regulators that are able to ensure that nuclear power plants are operated safely. We need a system to ensure security, non-proliferation. I'd say this is work for international organizations like the IAEA.
Another sensitive question about final storage facilities.
Yes.
enough. Where are they?
So, well, you said it's sensitive. I don't think it's sensitive. It should not be sensitive because I've heard all my adult life, we don't know how to manage the waste and so on. But actually, the scientists and the regulators have worked together for decades to come up to an agreement as to what is the safe way to dispose of the radioactive waste for thousands and thousands of years. And there have been a number of papers saying that deep geological repositories is the solution that countries should implement. So I agree that it's taken a long time for the first deep geological repository to be constructed. It's not yet in operation. I mentioned Finland, but actually Sweden is also constructing its DGR, its Deep Geological Repository. There's a project also well advanced in France. So this is happening. What people need to realize also is that a country embarking in a nuclear power program needs to think about how the waste ultimately will be disposed. This is an important consideration, and they need also to allocate funds all through the life of the nuclear power plants. This is also an important point that I wanted to make, maybe when we talked about costs, is that the cost structure of nuclear generation, nuclear electricity generation, includes the part for decommissioning, includes the part for management of the waste. This goes into the LCOE of nuclear. You don't necessarily have that for other technologies. But having those special funds created from the start of the nuclear program is very important. But the need to put spent fuel in a deep geological repository will not arrive before 40 or 50 years of operation of a nuclear power plant. So there are a number of projects: Finland, Sweden, France, Switzerland also. So these will happen. What I quite like about Finland is that the waste agency called Posiva created a subsidiary called Posiva International. It's a private company, and their business is to sell their expertise to countries that are looking to build a deep geological repository. And I like this example because it shows that from having been considered a problem, managing the waste in a deep geological repository could be a business opportunity for some companies. We know how to build, we know how to implement the safe operation of the disposal, and there will be a need. There will be a need to have several deep geological repositories all over the world.
Thank you. Thank you very much, Henri. I think we have addressed most of all the questions, and I really would like to thank you for your presentation today and for answering so openly to all the questions. Also, thank you to all the other participants and colleagues from UNC, from WFEO, and from the World Energy Council, and from all over the world who are present today. Stay tuned, because we will continue our webinar series, and of course, we'll continue our work on that topics. So, Henri, if you want to say, I don't know, a few words of conclusion, it's the floor.
Well, thank you for giving me the chance to speak. Maybe to people that are not so familiar with nuclear power, and I'm happy that we could have time to answer questions. If there are questions that I didn't have time to answer, I mean, you can forward those questions to me later. And just thank you for the opportunity.
Thank you. Bye.
Bye-bye.